Good morning, ladies and gentlemen. Dr. Garg, Dr. Vij, my senior industry colleague, Mr. Singla, Mr. Guduru, and Mr. Kuttavaraj, and Mr. Prasad. Thank you very much for giving this opportunity. The topic for today's discussion, which I was told, is green hydrogen accelerating green mobility. Green hydrogen ecosystem accelerating green hydrogen mobility. If you see in the world what's happening currently, July was a month where the temperature of the earth was highest. We are seeing the fires in Canada. We are seeing the landslides in our regions of Himachal Pradesh and Uttarakhand. More or less, this all are somewhere due to the global warming. If you'll see the various options available to handle this problem, as people say, this is happening because our excess use of the fossil fuel. If that has to be put it under control, then the ways to do is to look for options, look for fuels which are not based on fossil fuels. Green hydrogen and mobility. These are the two words comprising of the very large sectors. As I said, due to the issue which we are having on the global warming and the environment side, green hydrogen is going to play a very important role in decades to come in this century. At the same time, the mobility sector is also very, very important. We've seen it during the lockdown when there was restrictions on moving the goods and the passengers. I remember those days when I was in Mumbai and these migrant worker wanted to move back to their towns, and that pain we all have witnessed. What I'm trying to say that mobility sectors play also a very important role in economic development of any country and probably for our livelihoods. If you could put my slides, yeah, thank you. Can you just go to the slide number 2? So, when we talk about the mobility sector, next slide. Currently, world and therefore India is, these are some of the recent development which is happening in the world of the green hydrogen in the mobility sector. The first few buses have been put in areas of Ladakh by NTPC, which is going to run on the green hydrogen. They are also planning to set up the green hydrogen fueling station somewhere next year in May. Reliance, in collaboration with Ashok Leyland and Bharat Benz, has already put up the trucks and the buses which can run on the green hydrogen. Next slide, please. As earlier I was saying that currently our dependence on diesel fuel is very large when it comes to our transportation. We roughly import and consume almost 85 million metric ton of the diesel, out of which nearly 85% being used for the transportation sector. If you look at their carbon emission, which is somewhere around 210 million metric ton, and out of that, nearly 163 million ton is being emitted due to the use of diesel in the long-haul vehicles. The reason I'm focusing on the long-haul vehicle transportation, because it is in my mind, and the various reports, various experts says, this sector is the one which can be targeted to be converted to hydrogen first. Given the fact that, of course, all modes of transportation, including our passenger vehicles, also required to be move from the use of the fossil fuel to the non-fossil fuel based energy. And EVs are going to play also a very important role. So passenger cars or the short distance travel, electric vehicles are going to play a very important role. But at the same time, for the long haul vehicles, hydrogen is going to play a very similar role, and which can address the issue of the carbon emission through diesel. So if you can see in this slide that by use of hydrogen, we can nearly reduce the carbon emission by 95% compared to diesel, which we are using today. Next slide, please. A small chart, which shows that why long-haul vehicles are the one which are more suited to be converted to hydrogen. These are the vehicles which run for the long distance, carrying the load. So it is important that these vehicles are filled once and can go for a longer distance. Like hydrogen fuel vehicle can run up to 600 to 700 kilometers in one go. Compared to the EV vehicles, which has a battery and it has its own weight. So in this case, for long haul vehicles, having the liquid hydrogen can replace a diesel fuel very well. So it is easy to feel like a petrol diesel. It doesn't take a long time for charging the batteries. It also has the advantage of not loading the grid. As Mr. Singla said, that green hydrogen can play a very important role in replacing the fossil fuel in the industries. So if the same, this is also required to transmit power from one place to another place. So grid will already be loaded with that. So using the hydrogen at the filling station can make all sense in case of the long haul vehicles. Next slide, please. This system is very simple, that which we all know that green hydrogen can be produced through the electrolysis using the renewable power in the water. The same hydrogen can be through the caskets can be taken to the various stations where it can be fueled in the vehicles. Using the hydrogen fuel cell technology, these trucks can run with the hydrogen fuel. Next slide, please. Well, does it make commercial sense? Yeah, this is a very important thing. This point in time, if you compare with the prices of diesel and hydrogen, it does make commercial sense. Having said that, with the technology development happening in the space of the electrolyzer, coupling with the ever increasing price of diesel, in the future, this is going to make more commercial sense, such a way that the higher cost of the hydrogen fuel vehicles will have the very attractive payback. Next slide, please. What are major challenges? While it looks to be an opportunity, there are a few years to go by when we should be able to address this challenge. The one first and foremost challenge is availability of the green hydrogen and its cost. A lot has been talked about that currently, if you produce hydrogen with the fossil fuel, will somewhere less than $2, and with the electrolysis process, it is going to be around $5. So technology development are essential to make this happen, to reduce the cost of the hydrogen, and that will actually make all sense then after to use hydrogen for the vehicles as well. Other very important thing is the infrastructure. It is critical to develop infrastructure for fueling the hydrogen into the vehicles, and that requires the investments. in forefront of all, there has to be a technology development which is happening in all sphere of the this sector, including the technology of the fuel cells, including the technology in the electrolysis process. When we talk about the ecosystems, policy and regulation is going to play a very important part in first place to use the hydrogen in the mobility sector. Then it comes to off-takers. When I say off-takers, means the fleet operator who are going to buy trucks or buses which can run on the hydrogen, and along with that, the hydrogen producers who are expected to set up the plant in the country to produce the hydrogen. And financing is the important aspect for the developers of the hydrogen projects, as well as the fleet owners to get an easy finance. Next slide, please. So with this, I would like to give a brief background about my company, ACME Group. ACME is a 2 decades old company, very new company. Started with the telecom business, where they were having the patent those days for power interface unit, and because of that patent, in the telecom towers, the cost of the power has been reduced significantly to an extent of 60-70%. And with the help of that, the company turned out to be $1 billion company in a short period of the 5 years. In 2010, company has forte into the renewable power segment, like many other company. And currently, ACME has a portfolio of 5 gigawatt, including both projects under development and the project which are operational. Apart from the other around 2 gigawatts of project which has been developed and divested. So in this case, also ACME has paid the 3 cents, around 2 rupees 44 paisa tariff in year 2018, bringing a disruption in the market, and then it become the norms of the precedence of the power cost has now in that range, has gone up a little bit due to the prices of the steel and the cost of money. In 2018-19, companies thought to move to the green hydrogen space, and we started first pilot project perhaps in the world in the Bikaner, Rajasthan, which is running since last 18 months, producing 5 metric ton of the green ammonia, which is fully integrated project from renewable power through solar, making green hydrogen and then producing green ammonia. Yeah, next slide, please. So we also have a vision to have a project of 10 million metric ton by 2032. Next slide, please. So with that, we have started working on our first commercial project in Oman way back in 2019 and 20. This project also we are developing in the phases that Mr. Singla said that it makes all sense to develop project in a phases at the time the demand in the world will come. So we have our first project is a phase 1 project is 0.1 million metric ton, which is 100,000 ton per annum. We have signed the binding termship with one of the largest fertilizer company in the world, and we will be developing the rest of the phases as the demand in the world will come, which we are in discussion with the many customers globally. This particular project is located in the port of Dukkam, and this project, we've been allocated 92 square kilometer land in Oman, and first phase project construction we have started, that is for 100,000 ton. We've also recently done the financial closure of this project, which has been supported by the REC in India. Next slide. So along with the Oman, We are also developing two projects in India. One is in the state of Odisha and another in the state of Tamil Nadu. Both are also of the 1.1 million ton of size. Yesterday itself, we have signed the binding agreement with Tata SEZ for the process plant of our Odisha project for the 348 acres. We are also developing project in the US in the port of Victoria because the US also has a great potential of developing of the green hydrogen given their demand plus the IRA, which Mr. Singla has briefed about it. We also have signed an MOU with the government of Egypt for supplying, for developing the green ammonia project. Projects in India, as earlier speaker spoke, are largely, at this point in time, are the export-oriented project. And that's the reason these projects are generally located in the port areas where there is a coastal areas where the ports are available, like in Odisha. So it makes more sense to supply green hydrogen derivatives, which is green ammonia and even methanol, in the part of the East Asia, like Korea and Japan. And our other projects will supply green ammonia in the part of the Europe. Yeah, thank you very much for your attention, and I would be happy to answer any of the questions.
Thank you, Mr. Hiren Mehta, who is Chief Commercial Officer of ACME, and congratulations to your company for so much initiatives in this green ammonia and other. I think Mr. Mehta has very clearly brought out the use of green hydrogen in transport sector, and as you know that the transport sector is one of the largest contributor in pollution. In world, I think India is number 3 in carbon dioxide emission in transport sector, and if we can reduce the transport sector emission of carbon dioxide, I think we can achieve a significant level, and green hydrogen can play very important role in transport sector. And Mr. Mehta has rightly brought out right from electrical vehicle and how we can switch over to hydrogen and other vehicles, and this is a fact that once the policies are good, the green hydrogen availability is there. So definitely technology breakthrough can be there and we can use this. So any question from Mr. Mehta? Yeah.
Yeah, thanks a lot, Mr. Mehta. This is quite an enlightening session. Thing is that we are investing so much on green ammonia and green hydrogens. So there is any retrofit technologies are available to convert existing processes into green ammonia, green hydrogen. Like we have an ammonia processing plant and in fertilizer industry, but can it be possible to convert it into a green ammonia process? Is there any invention or is there any technological development happening in that sector?
Are you talking about converting the existing
ammonia processes into green ammonia process?
Yeah, look, the ammonia loop, which is going to be the common thing, that the process is same. From the green hydrogen also, you will be using the Haber-Bosch process and generating the green ammonia. I mean, it's just called green because it is hydrogen is produced with the renewable power. So as far as ammonia is concerned, it is going to be a same process. So I don't think so any retrofitting is required for using the green hydrogen in the ammonia process.
Okay.
Hope I got your question right.
Yeah, that's true. Actually, my question is landing in because developing new processes with green technology is again a capex driven. So probably some invention or something which we can able to convert existing processes into green technology, which might be more economical. That can be.
So currently, for the ammonia production, which hydrogen is being used the SMR process, which uses natural gas. I don't think so that it is possible to use the same process plant to produce the green hydrogen unless some very innovative technology development happens. Mr. Kochavraj can draw attention, or Mr. Singla can draw more attention.
If I can respond to that. The current ammonia plant, definitely some retrofitting can be done. See, 60% of the total capex is the renewable power. That renewable power will be required. Then 20% around is in the electrolyzer. That also will be required. So with this way, you get the green hydrogen. Then you can use the existing ammonia plant. But there also some retrofitting will need to be done, because currently the ammonia plants in the country, they produce nitrogen as well as hydrogen using the LNG, and that nitrogen and hydrogen is put into the reactor to make the ammonia. Here, what happens is hydrogen is produced, which is 99.999% pure, and then we capture ammonia through an ASU, ammonia separation unit, from the atmosphere, and then this nitrogen and hydrogen are put in the reactor to make ammonia. So that ASU will be required, some retrofitting will be required, and up to electrolyzer, that is the 80% of the total capex, will definitely be required. So there can be some saving, but not substantial saving in converting the current grey hydrogen into green hydrogen.
Yeah, so SMR process, that plant you cannot convert to green hydrogen, in my knowledge.
Okay, thank you very much. Thanks.
Any other question? No? Okay, yes.
It was very informative session, but the green hydrogen is basically the raw material of input is water. Am I right? And is that the fresh water, or can we are planning from seawater?
So most of the process plants, like I told you, they're likely to be export-oriented plants. So they're going to be set up near the coastal area, near the ports.
Yes.
So there, if natural water is available, okay. Otherwise, we can use the desalination plant, convert the seawater into the water, and then use it in the plant.
Are we viable according to desalination plant?
Absolutely. The cost of municipal water these days is not very small. The amount of money we have to pay for the municipal water, the cost of desalination water is almost similar.
As India is now, one of the worst scarcity of water.
We can use seawater. In fact, in quite a few of our projects, we are already planning desalination plant to use seawater.
So we can even get salt also.
See, the thing is that desalination itself is a very energy consuming process.
Yes.
And having said that, the cost is relatively going to be higher when you compare with the groundwater desalination, okay, or at least demineralization part, okay. So it's going to add up to the cost. It's not going to be just coming for the same price that you get it from the groundwater. So seawater desalination and demineralization basically is going to be a little more expensive. That is for sure. Having said that, another thing which I would like to add is there are technologies which are coming up just using the seawater directly for generation of hydrogen, which I'll be actually presenting today. Part of my work from there. And even not only that, we were quite successful in using the brackish water, which is the effluent of RO systems directly. And in fact, the textile waste water, okay, textile industry effluent, we could use to generate hydrogen directly.
No, but
okay. So which I'll be presenting and
contents of the water has a lot of parameters.
Certainly, see.
Parameters, yeah.
Exactly.
Because I was working on desalination.
Yes, exactly.
It is a very difficult,
Difficult one, yes. It's
in Gujarat I was working.
Yeah, because 1 kg of hydrogen needs at least 9 kgs of water. Or 9 liters of water easily, okay.
How about the biomass is going to play any role in green hydrogen? Because that has yesterday, the waste in India is a very high.
Yeah. So biomass does have the opportunities, but I'm not 100% sure how far it is ahead in terms of commercialization or even coming to the commercial scale. But it does show some potentials and promise in the lab scale or even at the pilot scale to some extent.
Okay, thank you.
Thank you.